Good afternoon, everyone. Welcome to our broadcast here at our California Academy of Sciences. My name is Josh. You are tuning in from our Morrison Planetarium Facebook page or OpenSpace on YouTube. We are very excited to see you. This is our virtual tour of outer space. Now, we have an opportunity here to explore the software called OpenSpace and do some really cool stuff with it. We are taking you on a tour that you get to decide. I'm the pilot, but you're the captain. If you've got an idea about where we should be visiting in the OpenSpace software, put it in our comments or chat, and we will very happily take you wherever you want to go. In fact, something that we are circling as we speak is a frequently requested audience favorite, and one that, as until now, we have been unable to show you. Longtime viewers might actually know what object I'm talking about already because of the context it's in. If you think you know where we are looking, please put it in the comments or chat, and we will award bonus points to the house of the correct guesser. I can see a whitish moon traveling around one of our gas giant planets, specifically Jupiter. Its surface is covered with cricks and cracks all along it, and there's some interesting color variation between the lighter and darker regions of the surface. If you think you know this mottled icy moon, let us know in the comments. I gotta say, this might be my favorite moon this week because I have been hankering to visit it for so long. And thanks to the tireless efforts of our engineers, they finally told me how to unlock it and get it working on my computer. Turns out it was much easier than I thought. But it's a beautiful moon. I feel like I've teased it enough. This is not Enceladus, even though Enceladus has a lot in common with it. Enceladus is another ice moon traveling around Saturn, and the ice moon Enceladus has a lot of geysers. This one has been seen to have some geyser activity, just less pronounced, seemingly less regular than Enceladus. This ice moon is Europa. Now, Europa is a beautiful ice moon. There's all sorts of cool stuff to see on the surface. Those cracks are one of the coolest features, though, not just in terms of temperature, in terms of interest as well. Now, using our planetarium magic, I'm going to take a second and turn off nighttime on Europa so we can see the entire surface. Looking around here, you might notice that some spots look much blurrier than even the spots next to them. It's because we took this image in strips, and some of them we have greater clarity than others. But I want to dive into one of these ultra high resolution areas. And when I do, let's look at these features up close and personal. Every so often on these icy surfaces, you can see a place where there's a line that's broken. Right here, I can see a nice one where there's a crisscrossing effect. One part is occurring more recently than another, interrupting a feature, sometimes even moving. Now, we can see a lot of features like that here on Earth because Earth has a geologically active crust. It's constantly moving and changing, and there's some evidence to suggest that the surface of Europa is probably similar. There's probably a lot of activity, moving and changing. That means the surface of Europa would be active. Now, that by itself is a super cool and exciting idea. The thought of an ice world moving would have to mean that there's some kind of activity underneath the surface, something moving around down there. We think what's moving is a saltwater ocean, a huge saltwater ocean, a ton of activity as the moon itself receives a gravitational tug, an influx of energy from its massive object it orbits, which is Jupiter. Every time it goes around Jupiter, it gets a little bit of a squish, a little bit of gravitational massage, and over time, that imparted energy keeps the moon liquid. I feel like we should do a whole show on Europa just because it is my new cool thing to show off, my new toy, as it were. So I might spend a little bit too long here. So if you've got an idea about someplace else we should be visiting instead of Josh's fun Europa tour, please, by all means, throw it in the chat. But until then, I just want to take in these vistas and see this super cool surface up close. You can see more of those crisscrossing cracks. Try and say that 5 times fast. Crisscrossing cracks. But looking around here, we can imagine some of those are caused by upwelling. Parts of the surface are warmer and they rise up because they're lower density. And as they push against the bottom of the icy crust, it might bend or buckle or break, allowing change and potentially powering some of those ice volcanoes, those cryovolcanoes. Ooh, you can see an irregular region up here. Check that out. Kind of looks like maybe Pinocchio. Got a long nose sticking out the front. When you check this out, I have no idea what would cause a little pool region like that. This would be a great question to ask some of our ice world experts. Some of these long cracks, very long, very straight. Now, we have reindeer at the academy periodically. We've learned that the reindeer really don't like crossing long, straight cracks on the ice because it could be something kind of dangerous to move over. It's cool to think about anything living on Europa, if ever there were found to be life there, would probably have a similar apprehension about crossing anything with a long, straight crack on it. Living on ice has to make you pretty cautious. Alas, no life on Europa that we know of yet, but we are planning on sending missions there to do a little bit more searching and a little bit more uncovering in the not too distant future. Now, we had a request from Corrie tuning in. Thank you, Corrie, for going to visit Saturn. Saturn is always a cool one to check out. And actually, we mentioned Enceladus before, Saturn's rings are probably getting a little bit of ice contributed from icy spray from moons like Enceladus. Now, looking around here, I'm trying to get us as close as possible without bumping into those rings. We can actually see a couple of the minor moons orbiting around Saturn, just as little points parallel to the plane of the rings. You can spot one just flew past us there, another one right here, another one there. These are probably pretty good-sized moons to be visible at this distance. The really tiny moons actually are nestled inside Saturn's rings, hanging out in some of those darker bands. What we see as dark is actually just the black of space shining through. Shining through might be the wrong word for the black of space, but we can see that darkness through there because there is less material reflecting light from our star, the sun. If we had more stars in our solar system, maybe another one hanging out, we wouldn't get such dark regions because there'd be less dark spots around us. We'd also see the rings lit from two different angles. As it is with our one star, you can only see that one shadow right there. It looks like a single bite taken out of the back. Now, that brings up another interesting question of how would our solar system work if we had more than one sun? It's much simpler with one star. Even though we have found solar systems out there with more than one sun, that would likely be a little bit more complex, a little more chaotic. Saturn is a beautiful object to check out, especially when we back up from it. You can see just how incredibly thin those rings are. From top to bottom, even with the most generous measurements, we say that they are about 1 kilometer thick. Now, that's the most generous measurements. I've also seen measurements that say the majority of the rings could be closer to 20 meters thick. It's only 60 feet for us imperial users. Now, 60 feet, we'd say it's about the height of our planetarium. Normally, that's a very good thing to reference for folks when we are inside our planetarium, but at your house, what's 60 feet across? What do you think? If you've got a measurement that you think would be a good reference point for 60 feet, please put it in the comments. I am always eager to see what people think of for spatial measurements. Okay, backing up from our friend Saturn, where else should we check out? We've had a chance to visit 2 whitish yellowish worlds. I think I have a good idea for another whitish yellow world. If we hear any other suggestions, though, I'm happy to detour. Right now, we are heading out to one of our 2 closest companions in the planetary part of our solar system. This is Venus. Now, as we zoom up on Venus, you can see that wonderful crescent shape. Why do we have a crescent Venus? Is this some special time of year? Turns out we see a crescent Venus because we are farther from the sun than Venus. So for different parts of the year, different parts of Venus's year, we get to see that crescent Venus. It just has to do with where Venus is in relation to us and the sun. Because it's closer to the sun than us, we get that distinctive crescent shape. Underneath the clouds, Venus is probably a very gray world, much less distinctive color than the top of the clouds. And it looks like Sanem has a great idea. Let's go check out Mars. Would you believe me, given the view we are seeing right now of Venus and the view we are about to see of Mars? I'm taking us there double quick. What if I told you Venus and Mars are the same color? Would you believe me? Sounds like complete baloney, right? When we look at their surfaces, we see Venus has those cloudy layers. Mars has a very thin atmosphere and that red-brown dust. How could they be the same color? It's the rocks underneath. When you look at the average color of rocks on Venus, they're grayish, at least according to our best measurements. When you look at the rocks on Mars, underneath that reddish dust, they're grayish too. Turns out most of the rocky worlds in our solar system are about the same color as Mercury. We think of Earth as a blue planet, but that's really only our oceans and our atmosphere working together to give us that idea of blue. Turns out our rocks average out to a pretty grayish too. 60 feet, according to Chris, is about 4 to 5 cars bumper to bumper in SF traffic. A somewhat pessimistic but accurate and realistic measurement. Thank you, Chris. That is great to think about. Now, looking around on Mars, I can give you the traffic report. There is not a lot of traffic going on the surface of Mars, but I can tell you it is about to double. What do I mean? Well, right now there is one Earth-made craft driving around on the surface of Mars, and there will soon be 2 Earth-made craft, maybe more, depending on how many of these upcoming missions are successful. We launched from NASA a mission to Mars, but we are not the only ones. There's a lot of space departments interested in exploring the surface of Mars. If you want to find out a lot more about Mars, stay tuned in the coming year. All of these scientific endeavors are sure to pay off, not too distant future. Now, checking out up here, we can see, again, on the surface of Mars, kind of that wrinkly stuff. This could be evidence of activity at some point in the past, but seems to be unlikely that there's anywhere close to the amount of activity we see on Europa or Earth. Now, there's potential for icy stuff on the surface of Mars as well, but probably not quite as dynamic or active. We don't expect to see an ice volcano on Mars, but we have reasonable estimation that there are glaciers at about 40 degrees above and below the equator. Now, that's a pretty exciting thing. Go visit Mars has previously been a challenging proposition because landing on the surface of Mars means you've got to bring a huge amount of water with you. How much water? Well, getting to Mars would take about 6 months. That means you have to blast off with 6 months of liquid water for your astronauts to drink on the way to Mars. When you get there and you land safely on the surface, you have to stay there for about a year. And that's because you have to wait for Mars and Earth to line up again just right before you could begin the return trip efficiently. And last, you have to have 6 months of water for the return trip. Now, that would mean 2 years of water, so that's pretty tough. We have ideas about how you could reuse water, but some people get a little grossed out by that. It's safe, though, and probably something our astronauts would just have to get used to. Now, another cool thing would be if there was water waiting for you on the surface of Mars. Getting there, mining ice, bringing it home, melting it, could be a great way for astronauts to build up a little bit of extra, have a secure system in place. You wouldn't be reliant on the water you brought. Probably would have made Mark Watney's life a little easier too. Unfortunately, he wasn't in an area that's known to have ice. In the book The Martian, we haven't had people on Mars yet. Now, one really cool thing is popping out because OpenSpace does such a great job of shadows, especially. We got to see the shadows of Saturn's ring on Saturn and the shadow of Saturn on Saturn's ring. We can actually see the shadow of Olympus Mons. Check that out right there. That's not the great dark spot of Mars. Mars doesn't have one of those. That right there is giving us the light of the sun hitting from this side, being blocked by that mountain and creating that nice dark shadowy pit. Ooh, we had a cool question come in about our moon. I'm going to see if Bing can throw that on the screen for us. But visiting the moon is a great opportunity. So Tony's asking, why does the moon always show the same side to us? Well, there's a lot of interesting discussion about why that side of the moon is so different than the other. But the simple fact is, it is quite different. There's a thinner crust and probably a lot more of the heavy iron-rich magma pointing towards the Earth side. Now, that magma hardened a long time ago to form these volcanic regions we see on the near side of the moon. Let me get us lined up just right from an earthly perspective. Doesn't that look just like the moon we're all used to seeing? One big problem. We have night on the moon. But if I turn off nighttime, that might look a little more familiar. Okay, so right about there should be the side of the moon we are used to seeing. This is the view we see from Earth. Sometimes of day, we might see the moon, sometimes of the month, we might see the moon like this. But that doesn't mean the side of the moon that's facing us is changing. It means the moon's position with respect to the sun is changing. Now, as the moon zooms around Earth, we get to see all those phases go through, but we never see the other side of the moon. If we really wanted to see that, we actually have to go to the opposite side, over here. Now, at first glance, you'll notice this side of the moon looks different. It's missing those dark regions. It has one, you can see up there, maybe two if you count the smaller ones down here, but not nearly as much as we see on the near side. That is the first really big change. Because we think this side of the moon is sort of the heavier side, it's the side that faces down, as it were, which is towards the center of the gravity well, which is Earth. Now, we actually see this kind of stabilization on a lot of objects. This tidal interaction, the tidal force on our moon, is what stabilized it over time. When we look at the moons of Jupiter, they similarly have a orbital resonance, not to the degree where only one side is facing in, if I recall correctly, but they do have a orientation to each other. The inner two, Io and Europa, might have tidal locking. I would want to double check that. But we do see a lot of the big moons in the solar system. Even planets like Mercury build up a kind of orbital resonance over time, where eventually one feature on the surface builds up a pattern with that side of the object is orbiting. Are there any missions landing on the far side of the moon? The Chinese Space Agency has actually gotten some missions down on the far side of the moon. And we've got some upcoming NASA missions designed to probe the icy regions of the moon, which, like Viper, are actually going to be pretty exciting to see if we're going to find ice way down here at the South Pole regions. Now, whether or not that lands on this side of the moon or this side of the moon, I don't recall. It is going for one of our pitch black craters very close to the pole, Shackleton, I believe. It's got to be one of these guys right around here. But a crater that is in total night all the time. Now, there's a lot of upcoming moon missions you should absolutely check out. A lot of upcoming Mars missions. It's a great time to be a space nerd. Does OpenSpace have Ceres? Oh boy, does it. OpenSpace has a lot of really cool objects, and you can pull in even more. When you pick a specific build of OpenSpace, the most current one is a ton of asteroids. But at the very least, we can show you the queen of the asteroids, which is Ceres. Now, there's been some big news about Ceres recently. That little tiny splotchy white feature we've seen previous weeks, well, we are now pretty sure that that was dissolved in liquid water at some point. And that probably means Ceres is a water world, much like Europa probably has huge subsurface oceans. Now, let's take a moment, just like we did before, and turn off our nighttime. Can you see those whitish splotches? That's some of the evidence we are using to show that Ceres had water-soluble stuff spilled on the surface, probably via water. Now, this does not look like Earth. This does not look like Europa. This does not look like a water world. So this is something of a surprising result, but one that's been a long time coming. The Dawn mission did a lot of exploring around Ceres and Vesta and taught us a ton about these worlds. And even years later, we are still analyzing that data and building a better understanding of these exciting spots in space. Now, again, you can see a huge amount of dynamic character on the surface. And I'm going to show you one of my favorite things about OpenSpace. Driving down onto the surface of a lumpy, bumpy world like this, you can kind of imagine what it would look like to be on the surface of Ceres. If you're a fan of science fiction, there's a lot of cool worlds that imagine places like Ceres as a place human beings go. One of my favorites is The Expanse, and there'd be a lot of activity on this major port in the asteroid belt part of our solar system. But just imagine driving or hiking or moving along here. Walking would be a little difficult. Ceres is a tiny world. You can tell that pretty closely based on its shape. So you would be very good at jumping on Ceres. I haven't crunched the numbers. It is a relatively dense world, which might change some of these, but it's smaller than Pluto, a lot smaller than Pluto. So if you went to go visit Ceres, you could probably jump far higher than you could on Pluto. And on Pluto, you can jump 16 times your current ability to jump here on Earth. So if you could jump, let's say 6 inches, because it makes the math easy. If you could jump 6 inches on planet Earth, you would be able to jump, 8 feet on the surface of Pluto, and probably even higher on Ceres. That means that if it was any smaller, you might have to worry about reaching escape velocity if you were a really good jumper. I don't think that's going to be a concern. It is a relatively large object for an asteroid, but small objects, small asteroids, you could probably reach escape velocity and blast off without a rocket pack. Moving away from Ceres, we have a favor to ask this week. For all of you tuning in, if you have the opportunity afterward, please fill out a survey. We've dropped in the comments right there, SurveyMonkey. This is a NASA product, something we are very excited to share with you, but it's something we really want to tell NASA how people are using it, what they're interested in, and what kind of takeaways they get from the programs they see. So if you are able to, please follow the link, fill out the brief survey, and let us know what you think of our programs and the software itself. We would really appreciate it. Okay, when on the way, let's see if we have any other suggestions. Let's see if there's something jumping out as a really cool thing to visit. I talked a lot about Pluto. I feel like I owe you folks a Pluto visit. So let's head there for right now. But if you've got an idea, throw it at me. Okay, blasting off towards Pluto, we get to see something really interesting. Going back to Tony's question, we asked, why is one side of the moon always facing Earth? Well, on Pluto and Charon, its major moon, one side of Charon always faces Pluto, and one side of Pluto always faces Charon. Imagine how weird that would be if you looked up into the sky from the surface of Pluto. You would see Charon just hanging there in the sky. As Pluto spun over the course of a night, you would see Charon hold still and the rest of the stars move. How weird would that be? Everything else in the universe would move except for that one giant round gray thing just hovering in the sky. That sounds absolutely fascinating. I hope one day human beings get to see that from the surface of Pluto. Hopefully they are in a very robust spacesuit, though. Otherwise, being on the surface of Pluto sounds like absolutely no fun at all. Now, when we look at the surface of Pluto, we can tell that it does love us as much as we don't love it because of that giant heart inscribed on it. Can you see it? Let's turn off our nighttime on Pluto. It looks like I sliced off part of Pluto. Turns out that's the part we don't have very good photos of. But the rest of it we have very good photos of. So good, in fact, we can zoom on down to see incredible detail. Little ice mountains poking out of this huge surface glacier. The mushy nitrogen hanging out on the surface of Pluto, if you brought it to Earth, would be the air we're breathing. Most of our air is nitrogen. On the surface of Pluto, it is so cold that that turns to this pasty, chunky stuff on the surface, but it's not quite solid. We think when something smashes into it, the rest of it flows over, so we don't see any craters on this surface of Pluto. In fact, we see very few craters in these mountainy regions, indicating they're probably fairly active too. When you look over here, you can see a little bit of an older surface. The amount of craters is used in astronomy to determine just how old something is and how long it's been bombarded by objects from space. I see Tony had another great suggestion. Let's go check out the sun. Let's go from the really chilly part of our solar system and go warm up a little closer in. Now, to get from Pluto to the sun would take us 4 hours if we were obeying the laws of physics. Thankfully, our show isn't that long and we can break the laws of physics, so we are heading to the sun in just a couple seconds. Zooming into the sun, we get to see an incredibly dangerous view. No human being should ever get this close to the sun, just wouldn't be good practice. Even looking at the sun from Earth can be damaging to your eyes, and really think about that. You're looking at something 93 million miles away, and it's still bright enough to hurt our eyes. In fact, if you go outside, you can still feel that radiant heat from the sun on your skin. It's incredible to think. I just have such a hard time wrapping my head around the fact that we are feeling radiant heat from an object that far away, and it's still warm to us. Now, granted, if it wasn't warm to us, if we weren't getting that much energy from our sun, we probably wouldn't be. We need that much energy to sustain life on Earth. So maybe it's sort of a self-answering question. But this is a very dramatic sun. Now, granted, our sun does have a lot of activity. You can see all sorts of different convection cells on the surface. But it turns out if you were to look for sunspots on our sun right now, it's actually pretty dull. The surface is very uniform, not a whole lot of change. We are at a solar minimum, and seemingly a super minimum. We haven't gotten any activity on the sun in months, except for a small handful of sunspots. Some people think this is boding towards a huge amount of solar activity, but we really don't have enough evidence to support that. That's an idea, but it's only that. It's possible that our sun will have a big flare tomorrow, but lower sunspot incidence now doesn't really support that. There's no direct correlation. Ultimately, our sun is a star, and stars are very long-lived things. Even the shortest-lived stars we've studied last for about 10 million years. That's a long time for human beings. When we look at the longest-lived stars, they might live for 100 billion. That's much older, much longer than the current age of our universe. So when you look at all these stars out there, they are fundamentally challenging objects to study. One day we might better understand our sun and its patterns, but that'll only be through careful study of other stars like our sun, trying to sample enough information that we get a better understanding of all of these objects. But if you've got questions about dwarf stars and their interesting characteristics, I would say tune in 2 weeks when we are going to have an expert on dwarf stars as our special presenter on our Cosmic Conversations. Her name is Eileen Gonzalez, a friend from college and a newly minted PhD. Tune in and watch her presentation. And if you have questions about these smaller class of stars, she is a great person to ask. As we're heading back into our solar system, some other really cool stuff coming up in the not too distant future. This week, tomorrow, Bing is going to be telling us about objects in our night sky. So if there's anything you have a hankering to check out, bring those questions tomorrow. On Friday, we will be hearing from an astronomy mentor of mine and former teacher, Dr. Adrienne Cool, and her group, the Astronomers for Planet Earth, helping us better understand our own planet and just how special it is. And boy, is it a beautiful planet. So if you folks are interested in any more of these offerings, make sure you tune in. Again, that's Night Sky Update tomorrow, Cosmic Conversations on Friday with Dr. Adrienne Cool. And in 2 weeks, we have Dr. Eileen Gonzalez talking about stars. And our Friday conversation next week, I believe, is Dr. Frank Marchi, both a SETI fellow and telling us some really cool stuff about an amazing instrument called the EV scope. So thank you for watching. If you have an opportunity, please fill out that survey. It would mean so much to us, our friends at NASA and the American Museum of Natural History. Thank you for joining us. Stay home, stay happy, stay healthy, and we hope to see you again soon.